Alright, in this video, we're going to be talking about synthesis reactions. Synthesis reactions are when small molecules or elements come together to form large molecules. So we could have hydrogen and oxygen coming together to form water, for example. So we have, in general, something small plus something small sticks together to form something bigger. That's what a synthesis reaction is. To illustrate this, what I'm going to do is I'm going to go through 3 different types of synthesis reactions, use some examples, and we'll get some practice balancing chemical reactions on the way by, which we still need to work on. So, the first type in general of synthesis reaction we're going to discuss is when some elements combine with oxygen to form an oxide, and we can call this oxidation or corrosion. In the case of iron specifically, we could call it rusting. So here, if we had iron, and he was going to react with oxygen to form iron 3 oxide. Iron, oxygen, and when I consider my crossover here, it says iron 3 oxygen. Excuse me. The 3 comes over to the oxygen, and the 2 comes over to the iron, and so that's iron 2, or iron 3 oxide. This is a nice little example too, because it's going to let me illustrate one more trick about balancing chemical reactions that you can use when you have an annoying situation come up that I'll show right here. I'm going to start with, as I discussed before, my metals. So 2 irons are going to 2 irons. And then when I go to balance my oxygens, I'm going to notice something. I have a diatomic gas here, and I have an odd number here. So 2 and 3. So there's no single number I can put in front of this oxygen that will solve this, that will balance this directly. But what I can do is I can use a fraction. If I use the fraction 3/2, then 3/2 times 2 would leave me with 3, and I'd have solved the problem directly. The problem with this approach is that, of course, there's no such thing as a fractional molecule. We can't have half of an O2 molecule. So when we get to this point, we always have to multiply through by the 2 to clear out that fraction, just like we would if we were solving an equation. So as long as I multiply every term, I can multiply by 2 and I can get rid of that fraction. So I'm going to do a times 2 to every single term here. So 2 times 2 becomes 4, 3/2 times 2 becomes 3, and 1 times 2 becomes 2. And now I've gotten rid of that fraction, and I have dealt with the idea that I had a diatomic gas going to an odd number, which otherwise was unfixable. Well, you could change the odd number and then work all the way back around through the problem, but that's the easier way to do it. Now if I look at this, I have 4 irons going to 4 irons, and 6 oxygens going to 6 oxygens. I'm balanced, I'm happy, and what I can see is I have a element and another element coming together to form a larger compound, and that's what makes it a synthesis reaction. Okay, next example. Magnesium metal, who can just hang out on his own, combines with oxygen gas, who's a diatomic, so we have to put the 2, goes to magnesium oxide. Again, my crossover here, +2, -2, cross them over, it's going to be 2 to 2, which reduces to a 1-to-1 ratio, which means I don't have to include it. Balancing, 2 oxygens on this side and only 1 on this side, so I have to balance the oxygens first. 2 magnesiums and only 1 magnesium, so I can balance out the magnesiums. I know I would say to start with the metal, but a lot of times you look at the metal and it's balanced, and then you go back and look at other things, so you have to go back to the metal. Element coming together to form a compound. That makes it a synthesis reaction. Last one of oxygen combining with things. Carbon combines with oxygen. Again, I have to include diatomic oxygen gas as a diatomic because that's how it exists in nature. And here I'm having it come together to form carbon monoxide. If there was an excess of oxygen in the environment, it actually would make carbon dioxide. But what we're going to assume here is there's not as much oxygen as we want, and so we're getting some carbon monoxide produced. Carbons are balanced, so I can't really start there. Oxygens, 2 goes to 1, so I need 2 of these molecules being produced, and that means I must have had 2 carbons in the first place. Small plus small comes together to form a larger synthesis reaction. The other two examples that I'm going to talk about is when a covalent compound can react to form an oxyacid, and this is going to show two molecules coming together to form a large molecule, or when a metal oxide combines with water to form a base. So let's focus on the oxyacid. Carbon dioxide, CO2, is going to react with water, H2O, to form an oxyacid. So if I put all these together, I can get the oxyacid H2CO3, or carbonic acid. Small molecule coming together to form a large molecule, and so that's a synthesis reaction. Metal oxides can also combine with water to form bases. Our example here is lithium oxide, lithium, oxygen. Be careful to do your crossover here. +1 and -2 crossover, so there's 2 lithiums for every 1 oxygen. That's going to combine with water, and it's going to form the base, lithium hydroxide. Now here I have 2 lithiums, and I have 1 lithium over here, so that's 2. And now if I look at everything else, I think I'm going to be balanced. 1 oxygen, 2 oxygens, 2 hydrogens, 2 hydrogens. I'm good. And what I see here is a molecule and a molecule coming together to form one big molecule. That's a synthesis reaction. So that's what synthesis reactions are, a little practice with balancing, and 3 different forms that you should be able to predict.